AIOs are all-in-one liquid cooling solutions for typically CPUs, and they rely on water to transfer heat from the chip to a radiator where convection, through the aid of fans, dumps this heat to atmosphere. In a nutshell, that's how these work. These systems are very popular with PC builders, but not all builders understand the benefits of larger radiators. Now you might be thinking, well, Greg, of course, bigger equals better. This isn't rocket science, but the degree to which bigger equals better is often misunderstood, as are the impending side effects. See, larger radiators provide additional fin surface area, which means more heat can be dumped every second, all other things equal. This may result in lower core temperatures, higher and more sustained boost clock speeds, and even longer chip lifespan. But larger radiators also allow builders additional flexibility when it comes to fan RPM. See, rather than aiming for even lower temperatures, one could just choose to reduce fan speed and maintain similar CPU temperature with a larger radiator. Some value that silence over pure speed, and larger radiators are perfect for this kind of application. To put these claims to the test, we put 120, 240, and 360mm Corsair AIOs through the ringer, isolating only a single variable in this case, and that's the size of the radiator. Everything else was kept the same. Our Core i7-7700K was locked to 4.5 GHz at 1.25 volts, and fan speeds were all locked to 1000 RPM. Pump speed was locked to 100%. Location was also locked to front mounting, and in this layout, the pump is sufficiently below barb height, so we're in no real risk of air ingress. The graphics card was an RTX 2080 Ti, and a Corsair iQ7000X was used to house these components. Room temperature was maintained at 24 degrees Celsius throughout. To stress both the CPU and GPU simultaneously, I put each setup through a 1-hour sustained IDA64 stability test, measuring both CPU package temps and GPU diode temps. After 60 minutes had elapsed, peak temperatures for both were recorded, and the process was repeated for each of these three most commonly used AIO sizes. I should also note that Corsair makes 280 and 420mm radiators, and there are actually some pretty major benefits choosing these over the smaller 120mm form factor counterparts, however you want to categorize those. So since these use larger 140mm fans, it means that these can turn at lower RPMs and displace equivalent amounts of air as their smaller counterparts. And inasmuch, if you wanted a standardized fan speed, 140mm fans displace more air than 120s, so either way, you're winning. The only real downside here is that not all cases support 140mm sizes. So for our first configuration, the 120mm AIO performed about as expected. I mean, considering we're cooling a Kaby Lake Core i7, the temperatures weren't terrible, but this size is really not ideal for chips like these with higher TDPs. Package temps touched 90 degrees Celsius. We did not thermal throttle. I want to note that. Thermal throttling, I think T-junction is at 95 degrees Celsius. It might be 100°C for these chips. Now, I know we said we intentionally mounted these radiators in the same location for the sake of consistency, but wow, does this thing look silly in such a large case. Moving on then, the 240mm AIO was up next. It boasts double the fin density, or fin, I should say fin surface area, not fin density, of the 120mm counterpart, as well as a second fan, right? And it was able to cool our CPU significantly more while under load, of course. Temperatures dropped to a max of 84 degrees Celsius, much more acceptable. GPU temps, on the other hand, they rose slightly, but this is likely a result of more heat being dumped by the AIO assembly in the graphics card's direction. If air entering the card is already hotter, then core temps should rise as a result. Though I wouldn't say 2 degrees Celsius is anything to really sweat about. I mean, we're still in the low 70s here. This is, yeah, not alarming for a 2080 Ti at all. I should also note that the 240mm form factor is a widely accepted size for many mid-tower PC cases, which are quite popular among PC builders. It's my go-to usually. If you're in the market for an AIO in general, the 240mm size tends to be a healthy middle ground. Next, we have the 360mm counterpart, and this one, it's about 50% larger than the 240, and package temperatures reflect this. At peak, the 7700K hit 80 degrees Celsius, while our GPU temps rose by a single degree over the 240 run. Again, more heat being dumped in its direction, so we really shouldn't be too surprised. 360mm radiators aren't as universally accepted by cases today as 240s, and especially 120s, but they're still quite common and provide additional cooling headroom for a fixed fan RPM. So there you have it, a quick roundup of AIO performance with standardized fan speed using popular AIO sizes. Obviously, if left untouched, right, your fans will ramp up and down depending on load, so fixing fan speed to 1000 RPM is a bit of a lab test sort of scenario, but at least this gets the point across about cooling capacity and TDP overall, the ability to handle certain CPU TDPs, especially when overclocked. A 7700K can be cooled by a 120mm radiator, assuming nothing's wrong with the chip or the rad, but it's not ideal. If you're looking for temperatures in the mid to high 70s, especially with a lot of these higher TDP chips, I recommend at least a 240 or a 360. I really wanted rad space to speak for itself. I mean, this is really no different than larger tower coolers versus smaller ones, right? The larger tower coolers can absorb and dissipate more heat per unit time, keeping core temps down and core clocks high, which should be the goal of any PC builder. But whether you're aiming for a quiet rig or a fast one, the benefits of larger cooling solutions are undeniable. In fact, the only real negatives associated with them are size and cost. As mentioned earlier, not all cases are going to support 360mm radiators, let alone behemoths like this 420mm here. It's just not going to happen. It's not how it works. A lot of builders nowadays prefer smaller, more portable solutions, or at least ones that don't weigh 80+ pounds when fully kitted out, like our 7000X here. And the price aspect should be fairly obvious as well, right? More materials involved in construction, new stamping processes, costlier packaging and shipping solutions, it all adds up. But if you can make it work, these larger liquid coolers pack one heck of a punch. If they didn't, why would Corsair sell them? With that, if you'd like to know where to buy Corsair AIOs like these, check out the video description. If you have any questions, leave them in the comment section below and consider subscribing if you have not already. That's all for this one. My name is Greg. Thanks for learning with me.